I'm a software engineer in IBM Research, and as Jayant mentioned, I did the course which has the unfortunate name called MSc Engineering from here. Yeah, 2 years back. So I'll be talking about this thing called how to train your computer. Okay, how many of you have heard of machine learning? Can you just raise your hand? Okay, so I think I should skip the talk rather. Okay, maybe not. Okay, so how many of you have worked in machine learning? Used the library, say, some library. Man, why am I giving this talk anyways? Okay, whatever. So let's start. This slides, like there are too many images, and if I start giving all of them credits too much, okay, I'll just have 2 slides only credits. Shamelessly download a lot of images from Google, better than downloading from Pirate Bay. So to start with, why machine learning? Why should you learn machine learning? What's the purpose? Okay, so the reason why I can entice you showing why machine learning is that these companies do machine learning. Okay, that is Google, Yahoo, IBM, any company you name, there's a very less chance that they don't use machine learning in computer science. Okay, IBM there because yeah, exactly. So the thing here is, if these companies use machine learning and you know machine learning, that means you can get a job there on a machine learning job, like what I do now. So we'll be asking, what do people apply machine learning in these companies? So let's say Google. So Google, this Google search engine. Yeah, Google search engine is like, yeah, the next to God. You ask anything, it answers you, right? So what Google does is it applies machine learning to figure out what you are searching for. And like we are terrible at asking the questions, and still Google manages to know what we want, right? So that is a machine learning algorithm running there. And the funny thing is, many people uses machine learning algorithm, and they don't know actually that they are using. Okay, it is so much part of our life, and we are like, no, AI is not there, but AI is actually there, right? So Google, the search engine, one of the finest creations of AI, and we will have a talk on PageRank by Divya on this Thursday, and for example, Amazon gives us these recommendations, and that's also another AI algorithm running in the back. It says that you have bought a camera, maybe you also would want to buy a lens. And the funny thing is, no one told them that the camera comes with the lens. It just figures out from the pattern. So that is the AI right out there. And for Microsoft, they have this Cortana now, right? So Cortana says like you just ask some question, it starts answering, and it also starts blabbering in between. That's what happened on the screen now, right? So that is the reason. So the one is that you can get job in these good companies. And funny thing is that there was an article a couple of years back. It says that data science, or the people who do machine learning, is called the sexiest job of 21st century. And it's not my words, okay? You can see this is one of the articles which was published in Harvard Review. And can anyone say like where that photo came from? He's an actor. Close. No. Wolf of Wall Street has nothing to do with machine learning or data science. Data science and machine learning are the same names here and there. Okay, so it's a Brad Pitt movie called as Moneyball. So what in the movie, what he does is like he uses statistics to make his super baseball team. Assignment to you, watch that movie tonight. Okay, next one. So this is another article which says that, again, the sexiest job of the century. And we have another Times of India article a couple of years back, again saying that data scientist is the next big opportunity to India. So why I'm showing is that there's a big opportunity for data science, and of course there's a dearth of people. You all should learn data science and come into this area. It's an amazing area. And the Coursera, the first course ever given in Coursera is machine learning. That's the importance of machine learning. So it was given by this legendary lecturer called Andrew Young from Stanford. And we have so much of this data science that we came up with our own icon called as the data science man. So whenever you have any trouble, he comes in like data science man. So it's so much happening in data science. But the reason that me and most of the data scientists or the machine learning people work in machine learning is not that we have this good job or this is the sexiest job in the century. We do it because machine learning is awesome and downright awesome. It has a lot of math, it has a lot of application, it has every good thing from every field. Okay, so for example, if you're like just doing the application, you're like, oh, I'm missing some math, like I can put up some cool algorithms, cool proofs. that I'm missing out. But machine learning has everything. Okay. Rather than looking at this application like Cortana or something, and rather than be like, oh, how is this done? Okay, how is it done? It's so awesome, and just being like telling that this is awesome. Why can't you be the magician behind it? Why can't you be the person writing behind the computer and writing those codes, which will do this magic? This magic we call as the machine learning, right? So that's pretty much about why you should do machine learning. And then let me talk about what is machine learning. We start with a simple puzzle. Who among these is Albert Einstein? The one on the left, of course, right? With the crazy eyes and the mustache. So the question is, okay, it's a fairly easy question. Even a fifth grader can answer that. So the idea is, how could a computer answer it? This is where the AI comes. We should always ask, like, how could the computer do it? Not how can we do it, right? So we'll say, like, well, why is it so hard? You can see that, the hair and the mustache. It's so easy. It's Einstein downright. But for a computer, it's not that easy, because computer doesn't see the things as we see. What computer sees is that the images are just, a matrix of pixels, right? So this is darker here, it's lighter here. That's what computer sees. It's just the same image. I just zoomed in, and it's not just this light and dark shades of white which comes there. What actually computer sees is just numbers. And if you actually start looking into each of these numbers, they are utter randomness. You can see like 36, 39, 112, it doesn't make sense. And what you expect from a computer is, take all this bunch of numbers in whatever order it wants, and you want the computer to say that is Albert Einstein. And that is where we ask the question, can you teach a computer to recognize this Einstein from this image? That's where the problem starts getting tougher, right? So the idea is, one way to do is like, I can save this image, okay, somewhere in the hard disk, and someone gives me the image, I can match it. What I'll do is like, I'll subtract the pixel by pixel. If the subtraction is 0, then that is Einstein. But now the question is like, what if there's a new image of Einstein? No, of course the subtraction doesn't give 0. Now we have to do something else, right? So that is a difference of machine learning and something called as memorization. I can't memorize. Okay, we can't just memorize saying that this is all the images of Einstein till now, and suddenly someone goes to the old album, figures out a new Einstein album, Einstein pick. We should still be able to recognize. But that doesn't happen if you're just memorizing and comparing. So that is where we'll be applying machine learning, which I'll be explaining lately. Okay. So to start with the formal definition of what machine learning is, so one of the pioneers of machine learning, Arthur Samuel, he called machine learning as the ability of a computer, right? So it gives a computer an ability which is not explicitly programmed. So this is the word, explicitly, right? So for example, every algorithm, every code you have written till now, mostly would be like add A plus B, right? Like that's the first, or print hello world. You explicitly say the computer to print hello world. But in machine learning, the idea is you don't explicitly say, but the computer does it by itself. Okay, that is where the difference comes between the usual programming and machine learning. Okay, so in his case, what happened is he was fond of this game called checkers. Don't ask me how to play that. I just know that he was fond of this game. And yeah, believe me, I'm not good in board games. Anyways, so checkers. And so what he did is he wanted to make a system which can play checkers with a human, right? So now it sounds very easy because we have this all like, online chess games, online checkers, everything is out there, all the algorithm. But this was in 1950s. Should think about it, just after the Second World War. So the thing is, it's very old, but he made a system which can play checkers with him. So the idea was, he made a system of checkers and he played with it for a while. Okay, then he started figuring out how to play better. Okay, it doesn't know the rules much. Excuse me. It doesn't know the rules much, but he started playing with the computer. Computer makes some, bizarre moves at the beginning. And obviously, computer loses. But he plays for a while and computer figures out the patterns. He figures out whenever this pattern comes, I should put the block here, there, right? So, then later what he did something tricky. So he figured out that if he has to play with checkers, he should rather get a, job of just playing checkers with the system, because you have to play a lot many times for the computer to figure out how to play. So what he did is he made one system play against the other system. So two dumb systems started playing against each other and they became brilliant, right? So what happened is the legend says that after a while he was not able to play against the checkers computer he himself made in 1950s. So that's the legend of Arthur Samuel. So you might have also heard of AI and machine learning. People keep changing the words. So I'll just you all have heard of AI, right? I suppose there are a course in AI in computer science as well. In BTech there is a course in AI, right? Yeah. So yeah, I didn't take a BTech in computer science, so I don't know much. Yeah, so machine learning is different from AI, right? So the idea is generally the AI focuses on intelligent systems, which is like pretty much like what I told now. But machine learning is a branch of AI, which is algorithms which learn from data. So the idea is AI also has this explicit algorithm. For example, the AI which plays chess is not exactly playing chess better because you play with lot many times, as the Sir Arthur Samuel did. What the chess algorithm does is that you play with it, and then the chess algorithm says like which is my best move, your best move, and it keeps calculating. There is nothing like you are actually explicitly programming to see like which is the way to move in AI. But in machine learning, what happens is you use this computer learns to play checkers over multiple games. You keep doing this. You keep seeing more data, and it tries to find patterns out of it, right? So I'll start with a very simple example. So anyone has any doubts till now? Yeah, I think I hardly spoke anything, but yeah. Any doubts? Yeah. Okay, I'll start with this. So okay, I'll start with this one. Assume that there's a farmer. I'll just give you an example of how machine learning works. Assume there's a farmer, like very rich, he has a lot of mango farms, right? So he has got this raw mango and ripened mango. And the idea is that raw mango goes to the vegetable stall and ripened mango goes to the fruit shops and fruit stalls, right? So he wants to separate this raw and ripened mango, right? He wants a system to do it because like it's manual labor, you don't want to do that. You want a computer to decide, given a mango, if it is raw or ripened. You want to make a system like that, okay? So the idea is, how do you input a mango into a computer? So what do you do? Like you open the hard disk, put a mango and push it in. That's not the way it works, right? So now the question is, how do we do it? How do you input a mango into a computer? Yeah, so we can input a color. So what do we need to input a color? We'll need some sensors, and a camera, right? So we'll have a camera. We'll input a color. So what else can we input? Wait. So we'll have a weighing machine, probably an electric weighing machine, because everything has to go to the computer. We can't just weigh it and then write it down. If I could weigh it and write it down, I would rather do it with a human, right? Yeah, hardness. So yeah. So hardness. So we'll have a measure of hardness. So probably in first year of civil engineering course, there is something called this crushing test. You put a 10 centimeter cube of cement and crush it. Similarly, we'll crush a couple of mangoes. Probably the mangoes will go bad though. Yeah. So those are the things. So these things we call it as features. So the idea is that whenever you want to put a real life thing into a computer, see, computers can only deal with numbers precisely. So what we do is we do some sensors, some numbers we take from them and give it to the computer, and then computer can decide, put an equation, do whatever it wants. Right. So the idea is, how do you input a computer? Into a computer, you put some features. So let's take this example. So this is some we just put some points, not a real life data. So assume that these blue ones are the raw mango and the red ones are the ripe mango. So and this x-axis shows weight. So you can kind of guess, right? I mean, ripe mangoes would be heavier than raw mango because they have lived longer, right? Before you plug it out. So the thing is, you can see that weight is not a good thing to separate this red from the blue. See, for example, by just looking at this weight, it's hard to decide, right? So the idea is you have to put in more features. So the one way is adding color. Okay, sorry, we have little video here. So if I add colors, probably this will happen. Okay, this is something which I just drew, but this will happen. So the idea is color will kind of separate, color and weight together will separate this raw and ripe mango. So now if we have this plot, we have this two information of each mango. These blue ones are the raw mango and the red ones are the ripe mango. We want to, given a new point, given a new mango, we want to know if it is raw or ripe. So what is the way of doing it? Okay, so the simplest way we deal with it is by finding a line. Okay, so we find this orange line or the green line. So let's stick to the orange line for the time being. So if I have this line and a new mango comes up, I'll take these two values, which is weight and color, plot them in this graph. Say it probably would come somewhere here, and then I'll see if it is on the right of the line or the left of the line, right? And now the question comes: how do you find the line? And that is what the textbooks are written about. Believe me, thick textbooks are written about these lines, right? So the idea is, if you have this point on the right, you call it ripened mango. If the points on the left, it is raw mango. Now you have to think, what didn't we do? We didn't explicitly say which are ripened raw mangoes and how to differentiate them. What the algorithm did is, algorithm found this line which separates them. This is where the explicitly programming thing comes. So now there is this question like, okay, we have this green line. Green line also kind of separates, but not in a good way. Is it good? It's bad, right? Because it's missing out some 2 points here. So the thing is, how to find this line needs a little of mathematical background. You will need to learn optimization and maybe a little bit of probability and statistics. And yeah, we call this color and weight as features. And there's a talk on Introduction to Optimization Thursday by Arun. So the Arun, as Jen mentioned, the person who envisioned the whole summer school. It's an amazing talk. He's an amazing orator. Should attend that. So so let's get back to this graph. So this line, right? This line can be represented y is equal to mx plus c. That's all linear equation. This m and c are the variables. So the whole idea of the algorithm is to just find that m and c. Okay. Now, if you get this m and c, you get this line. Now, I call this computer as an intelligent computer. Why? Because it has this amazing ability of finding which is a raw and ripened mango, right? So the idea is find the line, and that's an intelligent computer. Okay, now I'll go on and talk about what is feature extraction. So getting the values, these 3 examples they mentioned is the getting the values. So we will see what feature extraction is. For example, let's take a simple problem of spam filters. So all of you will be getting a lot of spams in your mails, right? So we'll see an example. So it says that 5th time writing some jackpot, some $50,000 you won because you are so awesome, right? So the idea is we need to make an algorithm which will, given the text, it will say that it's a spam or not, right? So assume this is the same problem. We are going to do it as exactly like the mangoes. So we need to have features now, right? We need to have some features to get it. So the idea is, because it's text, okay, so we'll take that each word as a feature. So the idea is, if it has the word lucky, then that is like, say there is one variable which say 1. If it doesn't have 0, something like that. So the idea is everything has to be numbers at the end. Million, if it is there, 1, otherwise 0. Jackpot lottery is there, otherwise 0, right? So clearly it's like a red flag, right? No one is so lucky in the world, right? So the idea is you should get these words, and then you should see that if these words are available, then it's a spam, otherwise not. Now the question is, how do you know these words are the ones which come in spam? So we'll do like the mangoes. We won't just go for just these words. We'll take all the words. So the idea is we'll take the dictionary words from, I don't know what that word to this word, okay? And you take all the words, and whenever the word is available, you put a tick mark. Whenever it's not, you put an X mark, right? And you convert it into a huge vector of binaries. So the idea is the first position here shows the first word there, and then probably this one shows the dollar here, right? So we have this huge vector, and till now in mango and the raw and ripened mango, we had this blue and red points, and it was just 2-dimensional color and weight. Here we'll have probably dictionary words. We generally deal with 50,000 or so words. So this will be a 50,000 dimensional vector. Now what we'll do, we'll find an equation for this one. And so that's how the spam filters work. So the basic point you have to check is which are the features. The features are the words here, right? So now again to check if you guys are awake. So can you get the features for given application? Yeah, by the yeah, okay, I'll tell later after these questions. Okay, guess the features. Okay, medical diagnostics, predict whether a patient will survive. To be honest, this is a part of a project which Adruba and I was part of. Okay, whatever. So anyone got any clue like what you should do? medical predict whether a patient will survive or not, what features would you take? Yeah, heartbeat, BP. So those are numbers. Yeah, anything else? Yeah, temperature. Temperature is a good one. Yeah, so basically most of these medical tests will do. So the things are like heart rate, BP, white blood count, age probably helps more. Yeah, and everything else, right? So another one, document categorization. So this is different from little different from spam filtering. So the idea is you have a document and you want an algorithm which says if it is sports, politics, or entertainment. Right, you will just go through the document. It will say if it is sports, politics, or entertainment. So what will be the features? Again, presence or absence of words. And we also have these fancier things called as part of speech tags, which are like noun, verb, and other things. And we also have this word count, how many times a word comes. So yeah. Another one is image annotation, car or not car. Given an image like this, and you want to say that if it is a car or not car. So what will be the feature? Yeah, wheels. Yeah. So the funny thing about this problem with wheels is that we have to make another machine learning algorithm which has to find a wheel in an image. So it's like a vicious cycle. You go and keep doing the same thing. So wheels is a good answer. The thing is, so the idea. This is where the tricky things come. So images you are given and you want to find a car in it. The way you do it is in signal processing there are a lot of techniques. So there is one technique to find circles. It's called Huff transform. So people can apply that and check for circles. Wheels, a difficult thing, but circle, yes, it can be done, right? So the idea is like you can look for the RGB pixels. They are like the numbers directly you can take. Circle detection, edge detection, corner detection, all those things. And if there is a corner this way, corner that way, you can just give it to the algorithm and tell it to find if there is a car or not. Okay. So there is a demo on ML on images by Gaurav. He'll be showing one of these coming up areas in machine learning, and one of these areas which are like probably going to lose our jobs because I'm not working on it, something called deep learning. So yeah, it's one of the upcoming areas and probably you should guys give it an attention. So that's pretty much about feature extraction. So I hope everyone got an idea about what feature extraction is. So next we'll go with what are the types of learning. So learning can be broadly classified into three of them. One is supervised learning, unsupervised learning, and reinforcement learning. And I'll be mostly talking about supervised and unsupervised, and reinforcement learning will skip. I think I'm going late. Okay, let me speed up. So supervised learning will again go to the farmer. So farmer has these mangoes. So the idea is you have a lot of data and you want to find something from it, right? So ripe mango and raw mango, and it's also given for you that you have some say 1,000 mangoes. Some people have sat and put them into 2 baskets, right? So and we have given this information about that they are ripe or wrong, ripe or raw, and then you have a learning algorithm. You give these inputs, and then you get a model, and that is this model in the earlier case is the line, right? If you give a new mango, it will tell you a raw or ripe. So this is basically a supervised learning algorithm. You are given the label also. Now, unsupervised learning, you don't have the label. You just have this mango. And you give it to the algorithm and we just come with clusters. It says that these green ones in one cluster and this, probably they'll put them in different clusters of different kinds of mangoes. Right? So unsupervised learning doesn't have the label. It tries to find patterns. It tries to cluster users. Not necessarily cluster, there are other ways, but mostly cluster these mangoes. So that is unsupervised learning. I'll get into more details of supervised learning. So the idea is learn a model from label data. Label means you have a label with it. It says raw or ripe. In the later case, we never had that label, right? So we have a set of features. We are giving it to a model, and the model predicts a label. Now, supervised learning is it's 2 types broadly in 2 types according to the output label. I'm all talking about the basic things. So if it is discrete, it's called classification. If it is real, it's called regression. So in our case of the mangoes, if it is raw and ripened, so it's discrete. So it only can take 2 states, -1, +1. If you call -1 as the raw and +1 as the ripe. But there are some cases where the numbers can be real. You want the computer to predict a real number, right? So basic idea is like classification and regression. In the case of classification, one example would be character recognition. Okay, so. One thing would be number recognition. So you have this 0, 1, 2 up to 9. You have the images of it. Your algorithm has to predict which, if given a new image, what number it is. So in this case, like you might want to find this car's number plate because it did overspeed, right? So the idea is you detect this number plate and you have these numbers. Now you want to search in a query and figure out who the person is, who doesn't know how to put the bricks, right? So what you do is you give each of these letters, give it to an algorithm, and it will predict which number is it. Is it 0 to 9, which one it belongs to, right? So here it's a classification problem. But the number of classes has increased a lot. Earlier it was just raw and right. Now here it has 10 classes. So that is one example. In the case of regression, one example would be weather forecasting. So the idea would be like you want to predict how much it will rain tomorrow or the day after. So you want to predict amount of rainfall. So yeah, just a quick question. What would be the features for rainfall? Yeah. We want to predict if tomorrow if it's going to rain. What? Yeah, humidity could be one. Temperature could be one. Atmospheric stability, wind, and of course seeding potential. God knows what that is. So the idea is you have the rain, right? So here the difference you have to like focus on is that the prediction is not binary. It's not going to tell you like how is it going to rain or not. What we are interested in, how many centimeters, how many millimeters it will rain. So the amount is a real number, right? So there's a huge difference between the earlier problem which I showed and this now, because the prediction has to be a real number, and the techniques changes a lot, believe me. Okay, so now we'll get back into unsupervised learning. So unsupervised learning, one of the very common examples of unsupervised learning is recommender system, and because you can see it's written here on the top of YouTube, which says that recommended for you, and probably you can see that one person who watched Star Trek will also be given as recommender system, Transformers, so geeky movies out there, right? So the idea is recommender system will look at your way of watching the YouTube videos and it will start recommending you. So you might ask, where does the unsupervised learning come? So the way it does is it clusters similar items. In the case it's the movie like videos and similar users. So the idea is like assume that I'm a big football fan. You don't have to assume I'm a big football fan. So the idea is that if I'm a big football fan, I'll watch some 10 football videos. What it does is that it figures out which videos are generally seen by the same people. So I'll be in part of a cluster of people. So that's what YouTube actually does. It figures out there are a lot of people who watch similar videos, and I'll probably in one of the clusters of football fans. And now if there's a new video coming up with, and people are watching in that cluster, it will recommend me. So the idea is, what it does is it clusters similar users. Similarly, it also clusters similar items. So the idea is there is a bunch of videos which are similar. For example, I watch one Friends video and it starts giving me a lot of Friends videos, because Friends videos, like Friends is a series, you know that, right? Yeah. So Friends, which is a cluster. So that's how recommender system does. And in the back, you can see that there's a machine learning algorithm and it does clustering and a little more sophisticated things. And one another example is image segmentation. And Sachin and I will be showing how image segmentation works in practice in the demo afternoon. So what image segmentation is, that you give an image, it will kind of segment the image and say that this is an animal and this is the offspring of it. And so given an image, it tries to put each part of the image into different groups. And probably the car image we gave earlier, if you give into this algorithm, it will tell that this is a car and everything else is different. So this is called image segmentation. It's used a lot in computer vision. Okay, and this also we use clustering. Why clustering? Because we are never going to tell that this image is this pixel belongs to this group and that pixel belongs. We are not going to tell that. What we want to do is that we give this image. It's going to take each pixel, put them in each groups. So the pixel which looks similar goes in the same group. Hence, you can see, right? Because this is probably where there's some couple of animals. The field probably this sand, right? Sand all has similar type of pixels. Hence, they come to the same cluster. That's why all of them are blue. So they come to the same cluster. But these animals, they are different. So this is how unsupervised learning is applied in image segmentation. One second. What is explicit programming? Sorry, man. I don't have a background in computer science, but yeah. What is explicit programming? Okay, you're saying that if you can. Okay, so the thing is, okay, let me think. See, the idea is, if this is a C, right? So we have to mention that these set of pixels come to the same cluster, right? If the C has this, say like for example, this is the C pixels. If the C comes with some other part of the image, this may not form a cluster. So the idea is that you can't mention that these range of pixel values will be in the same group or not. It solely depends on everyone else who is around. Okay, so the idea is, for example, this dome has, okay, let me take one example. Yeah, so this is a sheep, right? Probably a sheep. So sheep has all red color, okay, but it has varying colors inside it. But the algorithm still sees it the same color because of the context. There is like all other pixels are different, hence this should be the same group. If there was like other similar sheep color thing on the background, it might take that those and these are the same and have different clustering. So you are not explicitly saying which range of pixels is a cluster. The computer has to figure out by looking at these pixels.
Imagine the same image, the second last one, you will see the color of this, right now it is a black and white, which is the whiter side, right? The pixel value would be more towards 0, not away from the black, right? Imagine this picture in a color, RGB format, right?
Yeah,
yeah. Format. So there, this C would be in a blue color. So you can't really define like what the range for C, right? And again, if you like again apply one of the filters, right? Which have the camera, right? Again, it might change the range of this C color. From say like blue, not only from blue or white, it might be something like reddish. Like it might apply some sunset filter. So the range will again differ. You can't really explicitly program it like the pixel value is between this and this that way. Then only you will see it.
yeah. No, that's the whole idea of AI, right? That's why we are sitting and writing codes. Yeah. So we will tell how to do the clustering. We won't tell explicitly say the range. The range will be figured out by the cluster, the AI. Exactly. We'll explain that in the demo. We will show one algorithm, some fancier ones. Okay. So clustering also has this problem that clustering is not as, or the unsupervised learning is not as concretely defined as supervised learning because it kind of depends on the person who is looking at it, what clusters to form. Okay, so for example, if I am giving these images and I tell you like which all makes a cluster, for example, I want 2 clusters, which are in 2 clusters, right? So it could be anywhere. So one of the ways could be like all the cubes and cuboids are in one and all the fruits are in another one, and that could be one way of it. Another way could be like I clustered the colors, the red, the orange, the black, and the green. And third and not so good one is that everyone has a white background, this doesn't. Okay, so this whole thing can happen. And look among you, right? You have people coming from almost all parts of India, and now you are saying that I'm telling you like you guys have to become clusters, put into groups. What would happen? You guys, like, we can cluster you according to gender, we can cluster you according to the place where you come from, we can cluster you according to your interest in which area. So there are a lot of parameters, and this task of clustering, the making groups, are not that concrete. It can come with according to what you're looking for. So there is no unique way of clustering. That's an important point you have to take out. And then what clustering should I expect? And your algorithm, there are a lot of places you can change to make it give you clusters according to what you want for your application, which I'm not going to dive into, right? So we again got an exercise. Yay. So I'm going to give an example, and you have to tell me like if it is supervised or unsupervised. So you have a bank customer's profile. Should I sanction him a loan or not? What? Yeah, whoever says unsupervised, raise your hand. Okay, whoever says supervised. Okay, good. So yeah, so this is supervised because we'll have information from the bank and probably saying that this person we gave loan and he was able to repay, and some people who are not able to repay, right? So this is a supervised learning problem. So next one could be given an audio track, separate the singer's voice from the background music. Yeah, so this will be probably an unsupervised one because yeah, we may not have separately the singer's voice. Automatically group your personal collection of photographs in Picasso into categories. So this is also unsupervised because you don't have the groups already given. Oh, you guys are doing good, man. Sure, whatever. Yeah, given a patient's X-ray, may diagnose if he has a cancer. So this will be a supervised. Exactly. No, shouldn't have given this talk. Yeah. So the last and final type of learning is called reinforcement learning. Okay, and personally, I believe that this is closest to humans. Okay, this is pretty much like how we deal with the learning part. What it does is, it has this. We are not going to give it training set. Okay, what it does is it has this nature around it, has this environment. It tries out something Someone is going to tell it, no, you didn't do right, do it again. So that is how we work. Like for example, if I want to teach, like a kid want to learn how to walk, what it really tries to, crawl and then walk, and it falls down, and it learns, okay, whatever move I did was wrong, let me correct it. Then it tries out, like, 1,000 times start walking, and probably at the age of 1. So similarly, what we are doing here in reinforcement learning is we have a learner, which is an algorithm. It's gonna do some action. Action is probably like, putting your leg at the front. Now what happens is the nature will tell you, oh, you did good or you did bad. And it's also going to tell that what pose you are in. Because, see, for example, if you put the left leg up and the kid wants to know which leg to put, he should put the right one. So that's this part of called something like new state. He's in a new state because he has made that first move in the earlier state. So what reinforcement learning does is that you have this nature and you try out a lot of things. Nature tells you what to do, and then from that you learn and you figure out which is the best way to deal with. Right. So there will be a talk by reinforcement learning by Sindhu tomorrow in the afternoon, I suppose. And I'll also show you some fancy videos. Okay, before that, reinforcement learning examples would be like these games. So checkers, we told it was kind of reinforcement learning because he's not going to tell that which way is the way to win. The computer keeps trying, and the nature here is basically the computer, like the person saying that you lose or you win. Right, so that is checkers, tic-tac-toe, backgammon, and to add to the list, we also have AlphaGo. You might have seen the news. Right, so these are some typical examples, but believe me, there are a lot of applications, important applications as well. So I'll show you an example of a video. So this is a robot. Okay, so reinforcement learning is a lot used in robotics. So this is a robot which, looks like a spider with 4 legs. So the idea is it has these 4 legs, it has a lot of motors. Okay, there is a motor here, there's a motor in this joint, and there are 8 legs, probably like there are like 8 to 12 motors there. Alright, so now you want the robot to move, the walk. Okay, you want the robot to walk, but you are not able to do it because you have to synchronize all these 8 motors. Should it go up, should it go back, should it go faster, should it go slower? You have to do it. So the way it does is like reinforcement learning is there is a sensor here. Okay, it says that how far you are from this place. So what we are trying to do is like we are trying to make it go to the left, and you can try it. It's exactly doing what the kids do. It's trying out different things. It's not moving, but it figures out that after 4 minutes, it actually figures out how to move, how to put this, the way of doing it. You can see it has found itself one synchronized way of putting all the 4 legs so that it can move to the left. And we have never mentioned how to move to the left. So the idea is it just figures out by itself that which is the best way to move to the left. And Sindhu will be talking about them in detail, and it's an amazing area to work on, and it has probably the most overlap in robotics if people are interested in them. So, so before going to the cool things to do with ML, I have 20 more minutes, I suppose. If you guys have any doubts, you can ask me. Cool. Either I was not so clear or I'm too clear. Cool things to do with ML. Right, so I'm always excited about talking about this. It's one of the things which brought me into this area of AI, and there's something called as DARPA Grand Challenge. I was probably in like 3rd year or 4th year of BTech. It was out and a lot of videos, and I was very excited about this. So the idea is it's an international competition of autonomous ground vehicles, and this was before the whole fuzz about autonomous vehicles by Tesla and Google and everything started coming up. So DARPA Grand Challenge was a grand challenge by the Defense Ministry of Defense Project Agency of US. They told that people have to make a car and make it run from morning till evening through lots of distance. Whoever comes here the first wins. Okay, so it's a fully automated car with no one touching it. A lot of sensors. You can use GPS, whatever you can use, and you want the car to reach the end point. It's a funny video. You guys should go to YouTube and check. Another assignment after Moneyball. Right. So the idea is challenge is to make a driverless car, okay, without any human interventions. I'll show you a demo video. This is the car which was made by MIT. Again, as Jen mentioned, not the Manipal Institute. It's the Massachusetts Institute of Technology. So this is the car they made, and you won't believe me, this is 2007. It's long back. Yeah, and they had good technique. So you can see the steering and all is doing by itself. It's looking at a lot of sensors. There are a lot of sensors here and there, trying to control the speed. See, pressing the accelerator. So, so this is the like car people are trying to make, and it's a competition. And why am I talking about this? I want to talk like how machine learning was used in this project. Yeah, I think that's pretty much it. You can see how it evades those poles. Yeah. Now, so DARPA Grand Challenge was won by the Stanford racing team. Stanford is one of the finest universities in the world. And this is a person called Sebastian Thrun. And so the main thing we have to look at is like it used supervised learning to control the speed. So, according to Sebastian Thrun himself, what he did was he created this car. He wrote this equation saying that when the road goes to the left, steer it left and press the accelerator. When it goes to the right, do that. If they wrote all these equations, they had a huge supercomputer on the back of this Volkswagen car, right? Which has all these codes running. So the idea, he was doing all those, but the car was not moving as smooth as we wanted to move. So then he got this idea. What he did is he opened all the sensors, but he didn't allow the computer to run the car. He just ran the car by himself. He just opened all the sensors. He's like, okay, let me go around the world. He just ran it for many hours. And then what he did is like, whatever the move he made is what humans will make. Okay, and told that if such sensor values come, something like there's a road here, there's a payment there, there's a tree there, what a human does, that's exactly the same thing the computer has to do. So what he did, he incorporated his way of driving into this car, which they called as Stanley. So apparently they won $1 million. So that is how he used supervised learning, and it makes sense because he was doing rule-based and it didn't work out, and he just used supervised learning and it just bam, it just worked. So the other one is unsupervised learning. Unsupervised learning is like there's an image, there's a camera up front. There's actually more than a camera. These 5 of them are lasers, I suppose, and a lot of sensors. There's also a camera there. Camera can see the road. Now what you want, if you have the road, you want to separate the road from the grass or the pavement. Right? So in that case, they do this image segmentation, which probably uses unsupervised learning algorithms. So that is one of the success stories of machine learning. Another one is again cheap publicity of my company. IBM Watson won Jeopardy. How many of you heard of this thing, the Jeopardy and IBM Watson winning? Good. Okay. So Jeopardy is a quiz competition, and this was back in 2000. I don't remember. It's not that old. So what happened? This is a quiz competition, and a computer participated in quiz competition. The funny thing is, like, you give this natural language questions. You don't tell exactly like a Wikipedia search. You do a natural language question, and it kind of finds the answer. And it has also something with the money. The money is how the points come. It has to pick one area. The quizmaster will ask, and it has to find the answer in this limited time. It was one of the biggest hits of the time. It's still considered to be one of the pioneers of ML work, which is done. And one of the questions answer, I suppose, is Robert De Niro here. And it used a lot of machine learning and text processing behind it. And next talk, Rise of AI by Srijit, he'll be talking in detail about this Watson. Another one is, this is some fancy thing which I got from YouTube. So it's a robot playing table tennis. So this is a hand, and she's kind of teaching how to play TT for a hand, robo hand. So you have to first show. Okay, well, maybe oh, bad. Okay, one second. I wanted to show this part. Yeah. So the idea is, she will show something like 25 moves. You can show the whole hundreds of moves of TT, right? You can change the tilt, the bat. You can move. How many of you play TT? Okay, you'll play more when you get into office because there is nothing else. Yeah. So the idea is, if you play TT, right? So there are a lot of moves you can do. What it does is like it figures out how to combine these moves according to the ball. It learns how people moved it first, and it kind of uses it according to some supervised learning and unsupervised learning techniques. So you can see like they have actually made this system, and the idea is it combines a lot of moves. For example, one move like this, one move like this. They kind of do a linear combination of them. So this is like that later in the day when this thing started working. Yep. So this is one of the cool applications of ML. Okay, now it's my turn to ask. So I was given this job of asking you people a question so that I can give you. We got a prize. Okay, that's something which we need to give away. So the idea was that I should ask you a question and you should probably answer it. Okay, did I? Oh man, I actually didn't take much time. Good. So before that, if you guys have any questions, you can ask. Anyone has any questions? Yeah. Yeah, John Connor didn't make Terminator robots, if that is the question. Yeah, any question? Okay, so
Quiz time?
no, quiz time, but yeah, maybe. Okay, we'll ask this question.
Sure.
Okay,
Yeah.
so we have some prize for 1 or 2 prizes, right?
Yeah.
We have 1 or 2 prizes. So the idea is this will be like this because it's the first talk. I forgot to mention at the beginning. So throughout the summer school, I suppose
Yeah.
every talk we'll probably have 1 or 2 questions, which we are forced to ask, and you are supposed to get a prize, right? So the idea. So I'll tell you. So the problem is you guys are all smart, and if I ask you a simple question, everyone has to get the prize, and it's hard. We don't have those many prizes, so I have to ask harder question. If I ask a harder question, you guys may not get it. So I took that this is the question I'm going to ask. Identify cars in the video. So the idea is there is no one answer for it. Okay, there is no specific answer for it. If anyone has got any idea, raise your hands and you tell points, and then probably we'll decide. This is a bad job. I don't want to. Yeah. Yeah. No. So the idea is that identify cars in a video. Okay, let me make this question clear. So assume that you remember that car detection algorithm, like that the problem which we explained earlier. Assume that we are given a lot of photos of car, okay, 1,000 of them, and probably a lot of photos of non-cars. And now we have a video running, and we want you to detect the cars. So how would you do it? Yeah. Oh, one second. I'll just. Oh, the guy at the back, brown t-shirt. Yeah. You raise the hand first. You want to give the mic? No. Maybe it will take extra time. Speed mein ho gaya. Should have gone slow.
Since it's a video, we can just subtract the background and identify what all is moving.
Okay.
And since it's a video, we can just subtract the background, like subtract 2 frames every time, and see what is moving, and what is moving probably will be cars. And apart from that, obviously in an image we can find rectangular shapes and but the most effective I think would be background subtraction in videos.
Okay, so he has got the half answer. We'll probably. Okay, no. I need to tell why it's not correct or why it could be correct, right? So the idea is what he has mentioned how to detect moving objects. Probably could be car, probably it could be a scooter, probably it could be bus or a tram or whatever it was, right? So, but you still need to find out if it is a car or not.
Acha, only cars and not scooters.
Yeah. So the idea is like identify cars in the video.
Then on top of it, we can identify the shape of the moving object and see if it's approximately a rectangle or not. Then a segment trucks out of it, but it'll throw out scooters and all. By the area of the car to the area of the road, and
probably I should give someone else a chance. I think the guy in the white t-shirt. Yeah. After that, you can give to the red. Yeah.
Since it's a video, when the car is coming forward to you, closer to you, the shape of rectangle will definitely look bigger.
Yep.
So the thing should be the aspect ratio, not the size of the rectangle itself. And then you can use a sliding window algorithm to move a sliding window across the frames. And when the frame is closer, is the first half, you measure the aspect ratio and see if something matches the car in that part of the frame, and the aspect ratio will be different in the other half of the frame. So basically, just slide the window through the entire frame.
I think background subtraction would work faster, but you have to explain more. You can give to the next person.
I'm going to add to whatever he says. As he was speaking about identifying objects and the car, as the video moves, the image of the car keeps increasing, right? When it comes closer, we can probably use supervised learning on this bridge because we know what will be the average speed of a car, and we can measure the image size of when it will be at the end of it and when it's coming closer. So we can probably use the aspect ratio speed to check the image size and then identify it as a car.
Okay. Okay, so 3 of them, give it to 3 of them, and then we'll call it a day.
So I am assuming that nothing can be identified via road. Only the software would work. So the first thing would be the number of cars entering and the number of cars leaving, and that can be identified by the car algo, as you said. And for car algo to work, we can choose its features like headlights and other features. other features. To recognize the cars and simultaneously for each time the number of cars entering and the number of cars leaving. We can measure it by that.
Okay, the next person, I will quickly do this. Sorry.
Sir, we can first run the background subtraction as you mentioned. Then we can use at a particular distance the height of the object, height and width of the the moving object, so that we can identify a car.
Yeah, exactly. Yeah, most of. Next. Okay.
Since it's a car, we can, if we are having a video, we can have an infrared video feed.
Let's not.
Let's like with a heat sensor, right? Let's say with like we plot the heated points on the map.
Probably we don't have infrared. To be honest, it's very expensive to get.
And then we can have a point cloud library which can track the objects, and we can determine the size of the object. Once we know the moving points on the map, because of the heat map, and then we can track the size of the object. And given it's a proper highway, we know the speed of the cars. Okay, that is one factor. And second factor, we can use a supervised learning on the size of scooter differentiated between a car and a bus.
Yeah. Sachin. So to be honest, this is like an open-ended question. Let's just, sorry, it's already time's up. So it's an open-ended question, so there is no correct answer, wrong answer. There is like, it's actually very practically applied. Maybe people would do what you almost told, like the background subtraction is a good way, and how to get a background in another area of research. So the way they do is mostly the background subtraction, and they will also, as I already mentioned, we have these car images. We'll apply a car images, that algorithm, it will figure out which is a car or not. So you have to just give this block, and there will be machine learning algorithm behind it, which would have been trained over car and everything else. It will make a good decision, better than the aspect ratio. Yeah, to be honest, I mean, aspect ratio might be the features, but writing down the rules or figuring out what it does is probably hard. Now, one second.
Yeah,
how many
so
prizes do you have?
there as many as you want, but is there a clear winner or?
Yeah, that's the hard part, right? Okay, but still, give me a count.
3.
3. Yeah. So probably the first person he gave that detecting part, background subtraction. So,
Sure. What's your name? Sorry.
I mean.
Okay.
And the person in the black told like how to apply supervised learning.
And
then person sitting left to the white.
yeah, will you please identify yourself?
Yeah, sorry, man, I'm not good at assessment, but everyone else selects get more prizes in the next stage. Yeah.
Sure.
So the person in the black here, the specs, the third row left.
What's your name? Okay. Sure.
And the person in the back left to the white.
And your name, please? Uday?
Yeah.
Sujay. Okay.
Yeah.
Sure.
So no hard feeling. Sorry. Yeah. So let me just finish it up. I have 5 more minutes.
Sure.
So these are the resources. If you want to get into if you want to get into machine learning, these are the good resources. Forget about that price anyway. Yeah. If you want to get into this machine learning, there are like amazing textbooks written by Bishop and Tom Mitchell, and there's also one textbook written by a professor here. So you can actually go through any of these textbooks. This is actually good for introduction. And there's also a course on ML by Andrew Young, and there are 2-3 more courses again on Coursera on machine learning. You can all find it in YouTube and Coursera. It would be hard not to miss these people who helped in this PPT. So this is a talk we've been giving for 4 years now, maybe 5th year, and a lot of people has helped and they have contributed a little bit here and there. Most of them inspired and uninspired. So I would like to thank Hari Krishna, who is in Harvard, Raman, who is in Amazon now, Chandra, who is a PhD here, Sachin, he is standing here, and Lavanya, who is a PhD student. Yeah, and any questions? So yeah, just to mention, we have a lot of machine learning talks later in the day. So we have Rise of AI, and we also have a demo which Sachin and I will be showing. And we also have other talks on deep learning and knowledge graphs and other things. So yeah, keep looking for it and try to connect things like how what they are telling comes into this paradigm, how to apply this mathematics and here and there. Yeah, hopefully you all will end up doing machine learning. Yeah. Okay.
So, if there are no questions, then let's thank the speaker. So we'll break for